Okay, so welcome back to the third lesson in the 2.1 series. Today we're looking at higher calculations, and we're going to look at calculating the empirical formula and reacting mass of a compound. So keywords today: MR, moles, formula and proportion. This should all be in your class notebook, but if it isn't, then make sure you note it down. So I want you to pause the screen and I want you to have a go at these questions by here. Okay, so answer to the first one. What is the MR? So we're going to do element, how many, mass, total. Okay, how many? 2, 1, 4. 1, 32 and 16. 2, 32. Okay, and then 16 times is 64. Then we want to add all this together, so plus 32 plus 2, and that would be 98. Okay, how can you tell a chemical reaction is taking place? Fizzing, bubbling, gas given off, colour change, and you might see a heat change. Okay, what is the equation for working out mole? Mass over Mr. Okay, what is the test for carbon dioxide? Lime water turns cloudy. What happens at a destructive plate? So they move together, the more dense one goes underneath. Okay, and then you end up with mountain ranges. Okay, so what kind of the learning objective kind of suggests? So we want to calculate empirical formula and reacting masses. Okay, so these are higher calculations. These are calculations that will only come up on the higher paper. So first off, we're going to look at percentage yield just because it fits in quite nicely with the other calculations that we need to do. So percentage yield is looking at how many of our reactants, so the mass of our reactants and the mass of our products, and looking at even during the chemical reaction, what happens. Okay, so it's thinking about the raw materials and how many of the raw materials go in to make the products. So there is a little bit to think about. So percentage yield is the amount of product you actually make compared to what you should theoretically make, okay? So when we add these two reactants together, we should make this much product, but when we actually go to make it, we only make about 75% of that much product. So what's happened to it, okay? And how do we work out percentage yield? We want our percentage yield to be as close to 100 as possible. So this is the equation we use. We use actual yield over predicted yield or theoretical yield. You need to learn this, okay? Again, it will not be given to you in the exam. 100% yield means there is no loss of products. 0% yield means there is no product being made, okay? So we're going to have a go at an example. There's an awful lot going on here, okay? There's an awful lot going on here, but these are the kind of things that you're going to have. So limestone, calcium carbonate is used to make quicklime, calcium oxide for cement, okay? Gives you the percentage masses, but we don't actually need to worry about the percentage masses, okay? So theoretically, 100 tonnes of limestone should produce 56 tonnes of quicklime, but the actual yield is only 48. So you should make 56, so that's your predicted yield, but we only made 48, which is our actual yield. So when we put it into the equation, 48 divided by 56, remember, best bet is to use that fraction button on your calculator, press equals and then times it by 100 so that you don't mess up, okay? If you're going to do it like this, be really careful that you times by 100 after you've pressed equals, otherwise you're going to end up with quite a random answer, okay? So 87.5% is the percentage yield. So on this page then, because this is quite a nice easy kind of start to this lesson, I want you to have a go at these questions. pause the screen, think about the equation that you should have noted down and thought about learning. What are your answers going to be? Okay, so number 1, potassium iodide reacted with lead nitrate. The expected yield was 20 grams, but you only got 18. So you would do actual yield over theoretical yield and then times it by 100. And that would equal 90%. Okay, suggest 2 ways in which product could be lost. We're going to kind of leave that question because we're going to go through in a minute. A reaction produces 48. It should have produced 64. So we do 48 over 64. Times by 100, and that should give you 75%. What percentage yield for the reaction if the predicted formation is 21 but only 3.8 was made? So we do 3.8 over 21, and that gives us 18. Gives us 18%. So that's a really low percentage yield. The reaction between sulfur and oxygen produces sulfur dioxide. You should make that, but you only make that. So we do 384 over, and then times it by 100. Okay, so this is just working out percentage. It's a nice, easy question that could come up. If you get really confused, then just put the smallest number over the biggest number. Okay, that gives you 56.5%. Okay, so that's the first thing we're going to look at. The next thing, the next thing we're going to look at is why percentage yield isn't always 100%. Okay, so product can be lost when we filter or evaporate or transfer the liquids or when we heat it. Okay, so these are the kind of things that might happen. Why is high yield really important? Because we want to reduce waste. We want to make sure that we're using just the right amount of raw material. We want to make sure we're using just the right amount of energy, because energy costs us money, and then energy also contributes to global warming. And we want to increase profit. We want the largest amount to sell. Okay, so Jesse and Walter's boss is not happy. The product they made have a low percentage yield and lots of waste products are formed. This costs them money. The boss wants explanations. Okay, so pause the screen, think about what I've just explained and try and answer them 2 questions. Okay, so why is it less than 100? Product is lost when you filter. Product is lost when you evaporate. Product is lost when you transfer materials. So how could we improve that? We could filter more than once just to make sure that we're getting all the product out. We could use different apparatus when transferring. If we're worried about evaporation, we'll do it in a closed system, so even when it evaporates, it won't be able to escape. Okay, so there's a couple of things to think about. So moving on, we're going to look at something that's a higher calculation, so everyone is going to have a go at doing this in their exams, and it's called Empirical Formula. Okay, so I'm going to do this one, and then there's a couple of them to have a go together. Okay, so this is what we do. You've got 32.7 grams of zinc and 126.9 grams of iodine. We want to work out the formula. Okay, an empirical formula is the smallest ratio. Okay, so empirical formula is sometimes known as the simplest formula. Okay, so first things first, draw a table with a column for each of your elements. So I'm going to put zinc on this side and I'm going to put iodine on this side. Okay, then it says calculate the MR for each compound. So just need to look it up in your periodic table. Okay, so I use my periodic table to find the MRs. Then it says to divide the mass by the MRs. So we've got 32.7 divided by 65, and we have got 126.9 divided by 127. Okay, so then we're going to put our answers below. This one's going to equal 1. This one, 3.27 divided by 65, is going to equal 0.5. Okay, so done number 1, done number 2, done number 3. Divide all the elements numbers of moles. So this is what we've worked out, the number of moles here. So these are the number of moles, by the smallest value in the table. So we've got to divide each one by the smallest number. This is the smallest number, so we're going to do 1.5 divided by this, 1.5 divided by this. That's obviously going to give you 1. That will obviously give you 2. Okay, so we've worked out our formula. So it'd be Zn. We could put the 1 if we want, but we don't really need it. I2. So it'd be Zn I2. So that's the simplest formula. Okay, the empirical formula. So we'll have a go at another one. So next one, calculate the empirical formula of a compound containing calcium, and we've got 13.5 grams, oxygen, and we've got 10.8, and then hydrogen, and we've got 0.675. Okay, that's 1, that's 16, that's 40. Okay, so straight away I'm off to a good start. Next thing I need to do is divide and work out the numbers. Okay, so that's a nice easy one. That just gives you 675 again. This one also gives us 675. And then this one is 3375. Okay, so now we're looking for the smallest number. So it's obviously going to be this one. We divide them all then by the smallest number. So we're going to have 0.375 there. That's going to give me 1. 0.3375 there. That's going to give me 2. And 0.3375. That's also going to give me 2. Okay, so my empirical formula then is Ca, don't really need the 1, O2, H2. Okay, so we could write it like that, or we could write it Ca bracket OH with a 2, because there's 2 of each of them. Okay, so that's the simplest formula again. So what I'd like you to do now, there are 2 to have a go at. Okay, there's 2 to have a go at. I'd like you to pause the screen and have a go. If you're really not sure, go back and watch the examples a couple more times and then have another go. Okay, but if you are sure, have a go, put the answers on a piece of paper or in your class notebook, please. Okay, so here's the answer to this one, and here's the answer to this one. Okay, I'm just gonna, it's got a little bit stuck there. Okay, so you can just see how I've done it. I've got their mass, their actual mass, then their atomic mass number, then I've divided by the smallest, and I got 1 and 3. So that would be FeCl3. Exactly the same thing then here. Let's just come down a little bit. This one was a percentage, but that's fine. You can just use percentage values to make sure they add up to 100. So then I got 1 and 4. So that would be carbon and 4. Okay, so we're going to move on now to the final kind of higher calculation. So we've done moles, done percentage yield, done empirical formula, and we're going to do reactant masses now. So there are 4 kind of more complex calculations that you have to be able to do for chemistry. So we're going to have a go at this one as well. So what is the mass of iron that could be produced from 80 grams of iron oxide? Okay, so the first thing we need to do is highlight the key compounds in the equation. Okay, so we're looking at the iron and we're looking at the iron oxide. Okay, so you can essentially just get rid of them till you don't need them. Okay, so write down the mass if known underneath. So we know that there's 80 grams of iron oxide, and we kind of want to work this out, so we're going to call it X. Okay, because it's our unknown, we want to work it out. Next thing we're going to do is calculate the MR for each compound. So if you wanted to, and I would suggest you do it, you look at your table and you go, right, so element, how many, mass total, I've got iron, I've got 2 irons. The mass number of iron is 56. I've got oxygen. I've got 3 oxygens. The mass number is 16. So I'm just going to put that all in the calculator. 1, 2. Obviously, if you're feeling proper confident, you can do it in your head, but I would suggest you kind of just check it on a calculator. So that equals 160. So we've got our mass and we've got our MR at 160. So we're just kind of making a table here so we know what we've got at 160. Okay, then we've got iron. We've got 2 irons. You can see there's a little 2 in front. Know the mass of iron is 56. So we're going to do 2 times 56. So we know that's 112. Okay, so we know all of them. Okay, now we need to use another equation. Okay, so the equation is known mass over known MR times by unknown MR, and that gives you the unknown mass. Okay, so that's another equation we kind of need to remember to help us out. So I'm just going to slide, if I can. Yeah, I can slide that away. So our known mass, the mass that we were given, is 80. So that goes in there in the equation. So our known MR, which, because that's the known mass, they go together, so I did it in a table, is 160. Okay, our unknown MR is 112, because that's the one that we don't know, and that will give us X, or our unknown mass. Okay, so again, put it in a calculator, be really careful. So I do 80 divided by 160. I'd press equals, and then I would times it by 112. That gives us 56 grams, okay? So that's telling us that 80 grams of iron oxide will make 56 grams of iron, okay? So again, unfortunately, this is an equation you need to learn. We'll have a go at another one. So again, highlight the key compounds in the equation. So the mass of water obtained, so we're looking for the mass of water obtained when we burn 320 of methane. I don't know why there's I in there, of methane, okay? So we don't need that one, and we don't need that one. Draw a little table. We know that the mass of methane is 320. We do not know the mass of water. So next thing we're going to do is work out their MRs. So we're going to have 12 times by 1, 1 times by 4. That's 12. That's 4. That equals 16. So that's the MR of CH4. Then with water, be careful with water now. So we've got 2 hydrogens and 1 oxygen, but it's times by 2. So times everything by 2. So we've actually got 4 hydrogens and 2 oxygens. So we're going to do 1 times by 4 again, which is 4. And we're going to do 2 times by 16, which is 32. Add them together, that's 36. Okay, so we've worked out our masses. We don't know that one. We've worked out our MRs. This is stuff that we've been doing all along. Okay, nothing here is complicated yet. Okay, and then, oh, it's not going to let me. Okay, and then you just want to put it into your equation. So known mass over known MR times by unknown MR. Okay, so known mass 320, known MR 16 times by 36, which is our unknown MR. Like I've said before, I would do 320 divided by 16, press equals, and then times it by 36. Okay, that gives you 720. Okay, so an awful lot of water is going to be obtained when you burn methane. So finally, and then I'm going to give you a little challenge exercise at the end. Can you have a go at working out these 3? So again, pause the screen, have a go. If you're not understanding, go back and watch the video again, or watch that section of the video and have another go. Okay, remember the equation: known mass over known MR times by unknown MR. Okay, and that equals unknown mass. Okay, so if I was going to look at the first one, how much hydrogen is produced when I break down water? So we don't need that oxygen. So we've got H2O and we've got H. They've both got 2's in front of them. So I've got 6 grams of water. MR is 18 times by 2, which will give me 36. That's a known. We don't know that, but we know that we've got 4 times 1 will give us the MR. Okay, so put it in our equation: 6 over 36 times by 4. So let's put it in the calculator: 6 over 36 times by 4. That gives me 0.6 grams. Okay, so slide that to one side. Okay, number 2. Mass of calcium oxide produced when 10 grams of calcium burns. So we're looking at this one and this one. 2C, 2CaO. We don't know what that mass is, but we know that that one's 10. Calcium has a mass number of 40, so times by 2, that would have an MR of 80. Okay, so this one times by 2 would be 80, and then you've got times 16 by 2. So 80 plus 32 would give me 112. Put it in the equation. 10 mass, known MR, 80 times by unknown MR. So 10 divided by 80 times by 112. And that equals 14 grams. Okay, so when you burn 10 grams of calcium, you make 14 grams of calcium oxide. That's not bad. And then final equation then. Final equation. What mass of aluminium is produced from 100 grams of aluminium oxide? So we don't need the oxygen. Draw a line down. We know that we've got 100 grams of aluminium oxide. We have no idea how much aluminium we're going to make. Okay. Okay. So mass number of aluminium is 27. So we do 27 times by 4. That would give us 108. So the unknown MR is 108. Moving on to this side then. So we have got, so let's just draw this out a minute, think about it. So aluminium 203. So that would be 3 and that would be 2. However, you've got times everything by 2. So aluminium 2 times by 2 is 4. And then oxygen 3 times by 2 equals 6. So then we're going to do that times by 27, that times by 16, so that's 108. 6 times by 16 is 96. I can add them together. 204. So that is my known MR. Okay, so there is a bit to do, but they are going to be worth quite a bit. Okay, so then we're going to do known mass 100, known MR times by unknown MR. Okay, so we are doing 100 over 204 times by 108, and that gives me 52.9 grams. Okay, so final thing, and this just to prove to stayed and listen to the whole video. Challenge, okay, and I want you to write the answers on your notebook. So number 1, what's the equation for working out moles? Number 2, what's the equation for working out percentage yield? And then number 3, what is the equation for working out reacting masses? Okay, and I want you to comment them at the end of your class notebook. Okay, thank you.